Bonjour, bon après-midi, bonsoir to you guys watching me here in the live stream in YouTube, not in Twitch this time. I'm probably gonna stop temporarily streaming on Twitch, and I'm gonna focus on the YouTube channel for now. So this is a new concept. We've already done it in Twitch, but it's the first time we're going to play chess and be coding at the same time. So the basic idea is people are getting bored. Okay, they can no more do one thing at one time, especially if you want to catch attention in YouTube or whatever. You have to be dynamic, you have to do something different, you have to catch the attention. So I have to get the attention from you guys. So that's why I'm doing both chess and coding at the same time. We're gonna find an exercise of coding. I'm gonna try to solve it at the same time as I am playing chess, and of course you're gonna help me, guys. Okay, so let's start the clock in the chess. We're playing rapid today. Okay, let's start. Okay, wait a second. Okay, I think we're good. Yes, we are. Okay, let's play the first move, and I'm going to be reading. I'm currently reading the exercise at the same time, so I could explain it to you guys. So okay, so first of all, he's talking about penguins not finding the route or whatever in Antarctica, whatever. So we have to help them. I'm just scanning the exercise. I'm not reading line by line. Okay, we're working in mainly in the Walker class, which is this one. So what do we have here? We have a constructor, which is not set yet. We have a method called walk that should implement something which is not yet implemented, and we have the main method which will create a new object of the class walker, print it out, or print the result of the walk method in this class called walker. Okay, so what should I do? What are you waiting from me exactly? Okay, so we want to navigate through a labyrinth. This whole exercise is called labyrinth, which is somehow like a path that could be created through like a rectangle of cells. So we're trying to find the route to get from one cell to another cell. That's what I'm guessing. Let me just finish reading. Okay, let's play the next move in chess here. We're playing g6. Start until am Wahnsinn. Okay, we have another class called maze. Okay, we have another class called maze, which has public methods that could help us access labyrinths. or to debug the code. So it could help us give examples and test our code. So meanwhile, our friend Ahmed hasn't played yet, so he seems to be having internet problems. That's not our problem right now. So okay, let me put this here for you guys. Oh no, you don't understand. Wait. I'll translate this in English. Just give me a moment. Okay. The goal of the task is to implement the right-hand rule in Walker. Walker is a class, and thus be able to navigate through a maze, provided that the start and finish are on the edge. So the start and the finish should be on the edge. Okay, our friend resigned or had internet problems. We don't care. We just take the points. Okay, let's start again. Let's find a worthy opponent. We're playing against Mr. Volodomur from Ukraine. Okay. So let's continue reading. Provided that the start and finish are on the edge. In addition, the maze class is provided. This exposes public methods for creating and displaying mazes to aid in debugging. The maze in this task is represented by a two-dimensional Boolean array. The value at the place indicates whether at this place maze X and Y. So X is for horizontal cells to indicate which horizontal cell, and Y for vertical cells. So it's columns and rows. X is rows, Y and R column. Okay, I'm gonna try to read it in German and translate it to you guys. That's easier, I think. Dabei gibt es der Wert an der Stelle. Okay, so X, the value of X will increment while we are moving from left to right, and Y will increment if we're going from up to down. So zeros, if this is our maze, 0, 0 would be here, and let's say X, Y, which are both the biggest, are here. So okay, so this one is called width -1. Open eyes. Yeah, this is width. So this is 0, 0. This is width -1, 0. Yeah. Okay, let's play the next move. Bishop here. Very simple move. Okay, he plays this one. Let's add another move like this one. Okay, so we have a maze. We have the start and the end should be in the edges. Yes. And then okay, so okay. Sabret is dabei immer rechteckig. Okay, so the minimum value of our labyrinth or maze or whatever is 3 by 3. That's the minimum. So 3 by 3 is the minimum. And I think it should be a rectangle. It should be a rectangle. Yes, it should be a rectangle. So it could be 4, 3, for example. Okay, let's castle here. Okay, let's keep reading. It's -1. Okay, now I get it. So there are specific places for the entry and the exit. So we always enter from the cell 1, 0, and we exit from the cell width -1, height -2, which is probably here. So I will show you in here. Okay, so this is an example. Okay. This is an example. Can you see it? Okay, not fully. I'll try to. Okay, I think this is better now. Okay, so this is an example of labyrinth. Okay, you cannot see it. It's not very clear. I'll try to make it. Yeah, you know what? I think we can go here. the main idea about the exercise. We have like a maze, or it's called labyrinth, that we are trying to enter and get out of it, and each cell has coordinates, and we're always entering and exiting from the same cells. There are cells called walls that you cannot surpass, I think. So let's play the next move in chess, and then we will read what we should be doing exactly. Okay, let's play knight to c6. Okay, he jumps with a knight. I think I'm gonna take. I could take here, and okay, so if I take, he has to take my bishop first, right? And after I take, he will take back. So this doesn't work. Of course, if I take it and he takes with the bishop, he's in big trouble, because I will take his bishop, and I will be up 3 points in material, because the bishop is worth 3 points in material. So I should probably go ahead and take the pawn, the free pawn, and at the same time put his bishop in danger. Okay, so he will take first, very logical. Let's play few moves and then go back to the exercise. Okay, he's gonna think, he's gonna take his time, so let's keep reading. Okay, he played. Let's not give him a lot of time to think. Let's go here. Okay, so now we're reading about the class Walker. In the class Walker, you must implement the constructor walk. This constructor will get labyrinth, which is the maze, and result, which we'll be discovering next, as he will get them as arguments or parameters. Okay, and these should be saved in Walker, and then walk looks for, so the walk method looks for a way in the maze from the starting point 1-0 to get to the exit, which we said is a specific one. It's the red cell, which has a specific, I think it's the cell width -1 and height -2. Exactly, that's the one. So it will look for a way and the walker can only do okay, we could only do like vertical or horizontal steps, so you cannot go diagonally and move forward. You should just go vertically or horizontally until you reach your goal. Okay. Exactly. Okay. So the walk method will see for each specific time whether it is possible to reach your goal, which is the final cell, the exit cell. It starts from 1 0 and looks for a specific way, a specific trajectory for you to get to the exit point. Okay, so what's the result? That's the question. If we go to the walker class here, we find this is the constructor walker and this is the boolean walk. So walker will get the maze, which is a double array of booleans and results. So what's the result exactly? That's the question. What's the result? Let's read logging. Oh, first we have only 2 minutes left, so we have to play chess. Yeah, that's a good move, I think. The one he played. Now I think I have to simply exchange, maybe. Yeah, let's just go for it. Exchange. Is he going to take with the bishop or with the knight? That's the question. With which piece he's going to take? Okay, he takes with the knight. Now we go here. Very simple, just to kick the knight out, and once he moves away we will keep pushing the pawns, put more pressure on the bishop, or maybe go here with the knight, but after here, yeah, I'll just push. Okay, so let's keep reading. Logging. Okay. Okay, what to do now? I think I have to get my queen out, so probably wait. Okay, 1 minute left. Okay, he has 50. Okay, I'm just gonna move with the queen. Okay, I have no time to go and read the code now. I just have to concentrate on the chess until I gain enough time. Just take quickly, don't think, just basic chess. Okay, we have 1 minute. Sure, let's exchange. I have only 1 minute, bro. Of course I'm gonna accept the exchange. I don't want to give him this square, but I think I'm gonna play this. And after here, I'll go ahead and take. He will go ahead here. I'll probably go here. So yeah, it's worth it. I'm gonna go here. Okay, he goes there. Now we go back. I'm not the one supposed to press here. I have an extra pawn, so I'll just wait for the endgame. Okay, let's go here. Now that I have this great wall, I think I'm slightly better, especially with the extra pawn. I think I'm better. I'm just gonna keep playing with no blunders. I don't have to make great moves. I have to make decent moves, and I will probably win this game. Okay. Okay, 30 seconds left. What did he play? Okay, let's go here. I'm trying to double up the rooks. So if I take, I don't want to take. Maybe here. I'm gonna push. Okay. Of course you cannot take because I'll take the knight. If he moves the knight away like here, probably you'll do it. I'll just go. I didn't want to take, but I had to. Then I push probably. Yeah, let's go here. Bring the other rook here, or maybe here, maybe here. The good thing is I'm keeping my advantage and playing very carefully. One pawn is enough for me to win. I know I'm a good endgame player, so let's go here. Maybe I should have defended with the other rook. Yeah, I should have. Yeah, I should have brought the other rook. Okay, so he takes, which surprises me, to be honest. I take here. Nice. Okay, let's take with the rook. And let's pre-move this. Let me read the code, the logging. Okay, he plays that move. I'll go here, I think. Only 19 seconds. Wow. There is an increment though. There's 10 seconds increment. That's why I'm still alive. We simply go here, I think. Could have taken the knight, but okay. Let's take. I have double pawns, which is bad, but it's not. I don't think it's enough for him to get a draw. I'll try to win this game. Okay, now I have the 7th rank. Well, from my perspective, it's the 7th rank. From his perspective, it's the 2nd rank. Okay, we get the pawn. We'll probably get the pawn. No, we will not. He will play the right move. Now we go here, I think. The plan is very simple. Just get the rook with our first offensive piece now. And it's our dear king. He will march up the board and get us the win. The king is usually coward in chess. He'll probably sit back. Well, not only chess, he's generally very coward. I think I go here. And then I take the pawn. Yeah, I think that's the right move. Well, if he pushes, then I have to take. Because if he pushes and I don't take, I'm in big trouble. Now I go here. What is he doing? Just go here. That's a big mistake. He did a big mistake now. Now he's losing. He's 100% losing this game. Let's go here. If he takes, we move back. Wow, okay. Okay. Now. I think we go here. We grab the pawn. He'll grab the pawn. Okay, now it's over. Now it's over. He knows it's over. I think I just... Should I be taking? Okay, let's take. Yeah, he takes that one. He's simply not fast enough to do anything. We check him. Now we just bring the king, I think. Yeah, I'm not gonna let him win this game. What the fuck? Go here. This pawn is super fast. Okay. Go here. And go here. Oh, this is tough. I think I'm losing here. Or am I? Wait. Here? here. I'm not seeing a clear way to win here. Okay, maybe now. Check. That's wrong. That's completely wrong. I have to go here. If he takes, I will take the pawn, of course. Or maybe, wait. What if I check him? Does it go here? No, I take the pawn. We defend it. Okay, it's a draw. Okay, it's a draw. It's not a terrible. It's okay. It's just a draw because I spent 14 minutes out of the first 15 without increment, just reading the exercise. Okay. Just let me take some time to read the rest. So, okay, for the logging, let's open the logging. It's not a class. Okay, let's read another part of the exercise. It's called logging. Okay, I will put it here for you guys. CLV here. Here. Okay. So both in this task, are you seeing it? It's here. Okay. Both in this task and in many others, the solution of the algorithm is also checked. Therefore, all fields visited must be submitted to the test using the default result interface. A visit to a field can be entered there using the add location method. Okay, so all fields visited must be submitted to the test using the default result interface. Okay, so each cell should be visited. Okay. A visit to a field can be entered there using the add location method. Okay, so you use add location, and once you use it, the algorithm will check it using the default result interface. Okay, every square on which the walker stands must be logged, including the start and finish. Any turns on the field are irrelevant when logging and should therefore not be logged. Okay. Okay. Okay, so in the class worker we must implement the walk and the constructor. The constructor, let's run results. Dash and walker pass induction. Okay. So this so we'll start in Walker. We have to declare new private maze. We'll call it maze and private result, named result as it is named in this constructor here, and we will simply add this dot maze equals maze and this dot result oh sorry, it's not maze, it's just I think this is what should be done in the constructor. I think that's what I'm supposed to do. Okay, so the path is with yellow, is marked with yellow. That's the path. Gray is darker gray is a wall, so you cannot go through it. The exit cell is in red, and the white is for free cells. Okay. Exactly, but I just cannot get it. What's the path that we are going to be following? Like, are we going to start going down, and then when there is a wall, go like left? Sorry, go right, and then keep going right until there is no way to continue going right. So you go down. Yeah, it's okay. So what's the result in walk? So we have the walk. Okay, we are going to implement walk. That's our main goal. Okay, this walk method that receives. First of all, we have the constructor. What's result exactly? Okay, this is result. It's an interface that has a method called add location. This add location is implemented in the student result. It will print out this, and it will add a new point in the path. Exactly. Okay, this is not a very easy exercise. Actually, it's complicated a bit, so it needs time. Okay. So. Okay, let's start a new game of chess and think at the same time. No, this is not my level. I'm 1329. I should be playing 1300. Yes, 1388 is great. Okay, let's play the London system. As usual, I don't fuck with the London. Okay, so we have this is the walk. This is the walker. This is the walk. Method. Like, can I do it? can I do it in a different way? Like in a weird way, like just use it with a while loop, keep looking for free cell after another until I reach the goal. So how many choices do you have? So you're in 1-0. You can go here. This is the 1-0. You can go here or down. You can also go here. It's a Boolean array, so if it's true you can go, if it's false you cannot go, you cannot use that cell. Okay, so if, okay, now I get it. So if it's, okay, so it's many cells of booleans. If the result is true, that means 1. If it's true, then it is a wall. You cannot go through that. You cannot take that with the path. If it's false, you can put it in your path. Okay, now it's more understandable. Okay. Okay, now we get it. Okay, so let's remove this and start implementing. Okay, so he played the pawn to e6. So let's push pawn e3, preparing this this bishop to be freed finally. So I think it will go like it will probably not go up. Or maybe yes, it will go up. Okay, he goes for check. We just play this move to block the check. He goes there. Now we get the bishop out. We will soon castle, probably. So which function returns the boolean to know whether it's a wall or not? So there's a function or method called maze that will give us the true or false value to know whether it's a wall or not. Plus our path inside the maze. It's called maze. I think it's like if maze dot Okay, so he played this move. Yeah, let's just get the knight out. And try to play basic normal chess. Try to win. Yeah, okay. Okay, I'm too tired to complete this exercise. I have to just sit down and read it one more time, and probably tomorrow I'll solve it. But the main idea is that it's a maze. There's a specific cell that you're entering from, a specific cell that you are leaving this maze from, and we have to find the right path to get to the exit cell. How to get the right path? Well, each cell has a boolean value of true or false. If it's true, then it's a wall that you cannot cross, so it's blocked. You cannot move through that specific cell. If it's false, then we are safe to use it as a passage. And all of that will be programmed in a method called walk in the class walker. So that's the main idea. The thing that Boolean maze is the maze. It is the maze. It's an array of arrays. Okay, so array of arrays. It's a maze, but the problem is I cannot get it clear what result means. So result is an interface, and it has only one. It only has one implementation. The method of interface has only one implementation, and this implementation is basically adding a new point to the list of our path. So adding the new point. But where is the function that when we are calling it, it will return true or false for each? Let's try. Okay. Let's try with a specific. If maze to C equals to true, is that possible? Okay. Okay. I think I got it now. I think I got it now. Okay. Exactly. Okay. So he played this move. He went back with his bishop. Okay, let's suffocate him. See whether he will do this. Boom. Then boom. Sorry. Boom. 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 Yeah, he does. He plays it. I don't know if I'm gonna survive this. I hope if I survive this attack, I will win the game. 1000%. Okay, let's think about it. First, I have to go here to prevent this nasty move from the queen. Then I will probably go here, and here to free space, to free up space for my rook to be on a great open file H file, and it's more importantly for my king to be safer on G2 or F1 or even E1 maybe. Yeah. By the way, guys, this is a YouTube channel, so if you're watching, you should be subscribed. Because I'm streaming for you guys at 5 a.m. Okay, in case you're wondering why I'm a little bit, just a little bit low on energy, it's 5 a.m. here. Okay. Okay, so I'm gonna go. And go here. If he pushes, I will take. Okay, let's calculate it. If he pushes, I'll take. He will take, I will take, he will take, and then I'll go for here. Yeah, I think I'm gonna go here. Okay, let's try to go with the idea of okay, let's consider x and y are the coordinates, so we'll go for while. Okay, wait a second. Let's what if I go here? That would be a disaster. Yeah, I should be sacking here. Maybe I can't even sack. Wait, he cannot take. He cannot even take. He cannot even take. If he takes, I'll get him. So I think I have to save this square. How though? I don't know. But if he pushes, I can go here. I think I'm safe. I'm somehow safe here. Wow. I think I'm safe somehow. It's a miracle. It's a miracle. But I'm somehow safe. Because, okay, if he takes... okay, he moves there. Okay, he now realizes he's in trouble. Because I'm safe. I think I could go here. Let's see. He missed a huge opportunity to beat my ass. Okay, so in the first place, let's declare integer x equals 2 equals 2 equals 2 equals 2. So 1 we said, and integer y equals to 0. So these are the starting points, okay? And then while x is not equal to what is it called? Length, width minus 1. I think that's it. Yeah, width minus 1, height minus 2. Width minus 1, height minus 2. Maybe there is maze.width dot length no width. So maybe we should be determining okay, so let's see what he played. I think I'm gonna check him with the queen or with the... But either way, he's just gonna do this. So I don't think that's gonna work. Let's go here. If he takes, I will take. Then he'll push. Yeah, I'm in trouble now. Oh, I'm in big trouble. I blundered. Now he's gonna take the knight. This is bad. This is so bad. This is so bad. Just go here and pray. Okay. What? I just take, bro. Go here. Okay, I think I have hope. I'm not terribly bad, but again, it's the problem with the time. Okay, so now we have if made with length. How to solve this problem? Just a simple push of the pawn. Let's go here. I would like to exchange. I think he has more pressure. Should I be taking? Okay, let's take. And then go here, of course. I'm gonna remove this. Takes. Okay, I think I have an idea. We have, first of all, we have to save the length of the row and the column in that specific maze. Then we will know how to deal with each maze. So let's call the length of the row R and the length of the column C. Okay, now I think we go back here. Next move will be this one, probably. Or this one. This is very tricky, because I could checkmate him. Oh no, the queen can always block. So I'm probably gonna go here and try to check him and find more resources. Okay, he's trying to go here. I'll go here, go here, and then what's this? He wants to go here, so let's just make it look useless. Because what is he going to do after that? Nothing. Well, maybe he could do something. Because after here, he could sacrifice the bishop, but he doesn't see it, so I don't care. Let's go here. It's gonna be a draw. I'm gonna try to get to the draw. Okay, so let's save the length of each row and each. Okay, he did what I expected him to do. Let's go here. Okay, so let's go here and maze 0 dot length. Did he play? Not yet. Okay, what? I didn't see that? I'm so disappointed in myself. This is so bad. This is so bad. Wow, I just threw this game. Okay, looking back at code. Okay, just here, maybe? This is hopeless. Now this is hopeless. +6 is hopeless. If only I could find some type of perpetual checks. But I'm just too far from his king. This makes sense. Maybe. Let's try to... Maybe he doesn't see it. This is checkmate, by the way, guys. This is mate. Maybe he doesn't see it. Okay, now he loses to the bishop, I think. Okay, now he loses the bishop because only one move here. Only one move. This is the only possible good move. That's it. If he plays this move, he's safe. Otherwise, he's fucked. That's literally the only move. Or maybe this one also. Because after here, he'll just block. But then I take this pawn. Yeah. Then I gobble this pawn with check and I get another one. Okay, this is not the greatest move. This is a very good move, but it's not the greatest move. So he'll block. I will take with check and then take another pawn. Okay, now I have trying to find a way to... Okay, we'll just go here, sorry. So this is width integer width equals maze.length. Let's go back here. He goes for the check. Now we go here. He has this. I would take it. Yeah, I think I'm gonna take it. I don't really have a choice. I just have to... Maybe I will do it. Go here. There's no way he's gonna take. There's no way. He will not take. Yeah, this is lost. I tried my best. I was on a -6. Now I'm only -3, but it's still losing. Yeah, I think it's over. You just bring the king in. Well, he cannot bring it right now, but he will eventually. He will eventually. What if I go here? Problem is this is controlled by him. And I don't have that many moves left, so if I'm not defending this pawn, at least I have to gobble the other pawns on the other side of the board. Yeah, see, now I'm fucked. Okay, let's go here. It is probably over. He'll take. I'll go here. This is the Zugzwang. I'm lost. This is the Zugzwang. It's when you don't have any good moves. It's when you're obliged to play. You cannot pass your role in chess. You have to play, and each possible move, which are if you are very bad moves, like very bad moves. Yeah, now we lose. Maybe there's some type of stalemate. I don't know. I'll try to get some type of stalemate here. Okay, so this is the width. Length is equal to maze dot length. And then let's go back. Okay, play this move. Now we go here. We just try to get the stalemate, because it's great to have hope, and he's a very patient guy. He's a very patient guy. Okay, while x is not equals to maze dot length minus 1. No, let's just call it let's go here. Let's just call it length. I just don't have moves, so I'll keep. Maze dot length. This is height, sorry. This should be named height, of course, because it's the height. This is width minus 1. It's and or the other. Okay, he promoted to a rook, giving me further chances for the stalemate. I'm feeling that he's gonna give me a stalemate. Yeah, it's or, it's not and. Or why? is not equal to height minus 2. Okay, what should we do? Each time we have to change x and y. So we have to come up with an idea, which is I think we have 4 possible cases. So let's just go here. Okay, this could lead to a stalemate now. If he pushes the pawn, it's stalemate. If he pushes this pawn, it's stalemate. If he... Okay, he doesn't. Okay. I wanted him to blunder badly there, but he was... Oh, he has so much patience. He's so patient. Wow. Let's go here. And he has checkmate now. It's just here, checkmate. Oh, he doesn't see it. Is he trolling me? Is he disrespecting me? Let's go here. Okay, so each time we're gonna see if x and y are in... okay. So we're gonna go here, here, here. Let's go here. Okay, so if it's an if else. Okay, so if if maze x y x plus 1, let's try this one, equals to true. Okay, what happened? I lost on time? Great, okay. I was lost for a while there. So let's try to increment x and see if this is not a wall, so false. If it's false. False. So okay, so if it is false. So if it is equals to false, what we should be doing is we should go ahead and increment x. So x plus plus here. Then else if x minus 1. So we could go here or go back. Is equals to false. What we should be doing, of course, is x minus minus. So each time, if it's not a wall, then we are saving the new cell that we're supposed to be in. Okay. Else if maze x y plus 1 here equals to false, then it's gonna be just y plus plus, so we're moving up. And of course, if we're just exceeding the boundaries, we will not find the Boolean values false or true. So if we, for example, we find maze minus 1, 3, for example, minus 1 will not be in the maze. So this condition will not be true. So it will simply go to the next one. So the last condition, the last else, should be return false, because it's either we didn't find any neighbor cells that are true, or we're out of the whole maze, which is basically a failure. So, and the last else if should be if this one, y minus 1 this time, equals to false. Then we should decrement y, and then repeat this process many times until we reach, as I typed here, this. So here we should be adding one more last else return false. Okay, so if in any case we are in any cell and we didn't find any path, either this way, or this way, or we're out of the boundaries of the maze, then we will return false, and it's over. The walk method is over. Otherwise, we will just finish this while loop and then return true, because we reached our goal. I think each time we should be saving the new coordinates in the path list. There's a list called path or something. So there's a function called add location. So each time add location xy. Student results. Let's add maze dot add location. Oh, sorry, Walker. Anyway, we should save the new coordinates and the add location. It's in the result. Result.add location, I think. Result dot add location, exactly. X and Y. And this should be done each and every time. No. Just here. Yeah, add it here. Add it here. I think that's it. Maybe there's something wrong with the walker. Like, I don't know. I feel something is wrong here. Or is it? Let's see. Well, I can simply commit it. I think there is a problem. There's an endless loop here, I think. Okay. Stop. There's an endless loop. And that's a problem. We don't want no endless loops. While x is not width -1 and y isn't height -2. Okay. One zero. So there 1 0. Then the exit value is width -1, height -2. So width -1, height -2. So this is logical. But it could it endlessly be looking for the exit cell and not find it? Because it's always starting with x plus 1, so it's always incrementing x or decrementing x. Exactly. So yeah, that's the problem, I think. So for example, if we are here and we could increment x, but then we could not increment it one more time. Yeah, exactly. So we're here, we increment it. The next time, it's a loop, so the next time we could not go here, for example, because there is a wall. So we will not go down. We'll simply go back to where we were, and it will be an endless loop. So we have to solve this problem. Okay. What if we swap the x plus 1 with the epsilon with the y plus 1. So you go here. If you don't find it, you just don't go here. You go down first. What if you go down, you don't find one here? So this is a problem of repetition. There's an endless loop here, and the solution should be straightforward. The solution should be straightforward. If we go here, we don't find. I have to go down. Down. Okay, I think we should swap these two. I'm not 100% sure, but I think we should swap these two. Let's go here. So first of all, we increment x. Go here. If that doesn't work, then we go down. Right? We go down. And then if we in the next time we don't find another one here nor another one here, we should go here. I think now it works. Let's try. No, it's still an endless loop. What the fuck? 7 4 4 4 4. It's always a 4. It's always 7 8 or and there's always a 4. Okay, stop it. Okay, he gave me an example. Let's see the example he gave me. 1 0 1 1 1 2 1 2 1 3 1 4 1 5 1 6 1 7 1 5 then 2 5. Okay, let's play another game. Let's play Blitz game this time. I'm still not getting it 1000%. Why it doesn't work? Like, you go here, then you find this closed, so you go down. You go down, you find this closed. You try to go down. You cannot go down, so you go here. The problem is if you start repeating the same thing, it's a problem. Yeah, so if yeah, I get it now. If two of these conditions are true, for example, it will always choose the first one. It will go with the first one. That's the problem. because it will start repeating the same two cells. It would be like a ping pong ball between them two. So I should be finding a solution to that, which I don't know. For now, I just don't know what's the solution to that. So maybe if we swap these two. I don't think this will work. Let's try. Yeah, the same problem. How to solve this problem though? Okay, I don't think I have the solution to this for now. I think I did enough today. Yeah, I implemented the code, but there's only one piece left, which is how to prevent the repetition of the same segment of path repeating endlessly. Okay, when you go to a cell, you only go back to that cell once. So maybe we save each time in each loop. We save the coordinates. Let's call them, I don't know, x1 and x1 and what it's called in English, what the fuck, epsilon, and yeah, I think I have to sleep now. Okay, so we save the coordinates each time and we compare them to the new coordinates, and if they are the same, no, they cannot be the same. If they are the same as the previous ones, then we should change. So this is really, it's not tough, but I just feel that I cannot think right now. You know what? I think there is a solution. I just don't know exactly what it is. Maybe. I'm gonna ask ChatGPT. Yeah, he's saying the same thing that I said. You should try to go here, then up and down. If not, okay, so I have to add something to my code. ChatGPT is saying it's the right idea, but there's something missing. Like, this endless loop has to be there for a reason. And I understand it. It will simply go up and down or left and right, because if, else if, else if, else if, they're in the same order each time. So maybe if we can change their order. Okay, let's play a blitz game before we finish. I'm trying of a solution. What's the right solution? What is? Tell me how, tell me how, tell me how, tell me how. Ooh. I can we live together. Yesy Fauzi. Okay, now okay, let's try to think more like in like an open-minded person that is not very tired. Okay, let's try to think like a normal person. The way is the right way is to order it in the way that if you go back to your previous. Okay, let's test it out first of all. Let's try to test it out. Commit result and worker, commit and push. Let's go through as a message and let's commit. Commit anyway. Push. Okay, so he played this move. Let's play this move. I think I'm having technical problems. Am I? Okay. So what's the problem? I know what's the problem. How to solve the problem? The problem is, okay, if you do something, if you do x plus 1, you should not be doing x minus 1. You should not be executing x minus 1 with the next move. So if this is x plus 1, x minus 1 should be in the last place. I think I got it. Wait. I think I got it. Wait. So we add new integer I, for example, equals to 1. Okay. An integer j equals to 1 also. And then, okay, we just play whatever. We go for check. I don't care. I have an idea. Let's go here. So I and j will count how many times x plus 1 and then x minus 1 happened, or y plus 1 and y minus 1. And if it happens, like twice in a consecutive way, yeah, if it happens twice in a consecutive way, then we should return false, simply false. We will not reach the end, probably. Or not that. No, I lost some time, sorry. But if it is equal, so if I is equal to 0, so here we will add I plus plus, here I plus plus, here I minus minus. And if it is equals to 0, that means it did happen twice. And once it is equal to 0, then we should change. It's either we return 0, I think I got it. I'm not sure. Okay, so you can think of I as a balancer for the incrementation and decrementation of the x and y and j as the incrementation and decrementation of the columns. So here let's set it to 0 and here to 0. Okay, now if this happens, I plus plus. Okay, if this happens, I minus minus. Okay, wait, okay. Yeah, I don't think it works. I don't think it works. I was thinking if we move this way, we add I plus plus, then if we move this way, I minus minus. And whenever we find I is equal to 0, then we are repeating the same moves. But I don't think it works. Or does it work? Okay, I'm gonna try it. I'm gonna give it a try. If it doesn't work, it doesn't work. Here, I equals 0. Here also 0. J here should be 0. Here it should be J here should be plus plus, and here should be minus minus. Exactly. And here we should if I is equal to 0, you know what we should be doing? Or not here, maybe in the last one is better. because we know in the last one that we tried all of them and we couldn't find a way other than to decrement the x. So if I return false, I think. Yeah. I'm not 100% sure, but yeah, I think that's it. Let's try it now. Okay, 3 4 3 4 3 4 3 4. So 8 3 4 8 3 4 8 3 4 8. So moving up and down. Okay. So we're moving up and down. If j is equals to 0, return false. Okay, so it worked. Did it work? Oh, it didn't work. There's a problem here. Okay, why did we stop here? We're not supposed to stop here. We're supposed to stop here, I think. Okay, why didn't we move like here and continued? We moved to here. We shouldn't have stopped here. We could have gone x minus 1, right? 8 3 8 3 8 2 8 3 8 3 8 4 8 3. So we didn't reach this one. That's the problem. We're doing this. If I equals to false, and do this maybe? Okay, we're very close. Not there yet. What's the problem here? Okay, let's try it now. So now it's an endless loop again. No, that's the problem. Okay, let's go back. Control Z, I think. Okay, let's give it one last try. If I is equals to 0, this is what we do. I think so. We try this. Else, return false. And here G. Here G is equals to 0. G plus plus is 0. Here G minus minus. And here I plus plus. G equals to 0, I think. Should be. X minus 1. If X minus minus. This is okay. This is for X minus 1. X minus 1, okay. Is it Y minus 1? And then we add this. If J is equals to 0. This is the last try, guys. I'm gonna die. If J is equals to 0, then we copy and paste the incrementation and decrementation of X and only X. So X plus 1. And then X minus 1. Because we moved up and down. And then yeah, here else return false. And I think that's it. Here J equals to 0. Yeah, here we end it. So we have, this is the first big while loop. Great. This is the first if. X plus 1. X plus 1. Big minus 1 should be ending here. Minus 1's. exactly if j is equals to 0, if x plus 1, otherwise if x else. Here. Yeah, okay, I think that's it. Let's see. Okay, there's still a loop. Yeah, there's still a loop. I don't know. It's supposed to work, but whatever. I added the I and the J. I thought the counters would save it, but they're not able to save it. Okay, whatever. Yeah, whatever. Okay, I think that's it for today, guys. I introduced to you a new theme, a new way of giving content to you guys, which is chess and coding at the same time. I try to share coding with you guys. I tried to add the J and I counters to balance. So if there's an incrementation in X, I add I plus plus. If there's a decrementation, I decrement I. And whenever I go up and down or down, I reset I to 0. Yeah, I reset I to 0. And then whenever I find I equal to 0 again, when we increment it or decrement it this way, then it would just return false because it's an endless loop. After we check the up and down, of course. If we check the up and down and they're both walls and it's impossible, it's an endless loop, so we return false. But there's a problem with that. I don't know what it is exactly. I will find it in the morning because I'm so tired now, guys. I hope you like this live stream, and there are many more live streams to come, so I hope you guys hit that subscribe button below, and why not share this live stream. You will find many shorts and many videos in my YouTube channel, as well in my Twitch channel, Lou Plus Las, that you can see in the stream. This way, it's this way. And yeah, that's it. Have a great day, guys, if you're waking up right now, and I see you guys soon. Bye, guys.